everybody. Really intriguing, exciting chat about ultra low power wireless technology with embedded AI. Scott, how are you?
Very good. Thanks for having me. Happy to be here.
Well, thanks for being here. I'm really intrigued by your story personally and the mission of you and the team. Maybe introduce yourself, the company, starting from your groundbreaking PhD research all those years ago
Yeah.
onwards.
Yeah, thanks. So I am founder and CTO at Ambiq. We are a company that's putting intelligence everywhere. So what we have is we've got a unique, extreme low power technology that allows us to build really anything with less energy. So in this case, low power microprocessors. They consume anywhere from 3 times to 20 times less power than what's out there. And so if you're a company building a battery powered device, you want to put intelligence in that device, our solutions are the ones for you. And it's a technology based on subthreshold and near threshold circuits. This is it's actually a concept that's been around for decades. So if you go back to the 1970s, subthreshold circuits were first theorized, and early work was done in the wristwatch industry. But Ambiq is the company that has built an entire platform around that. So we have a complete circuit design platform. We can build anything we want. If you look at our portfolio of products today, we have little wireless chips that are used in consumer wearable devices. They're used in medical devices. They're used in smart credit cards, industrial sensors, all sorts of things. And it goes back, as you said, to PhD research that I was doing back at the University of Michigan. So I was back in the late 2006 to 7, 8 timeframe. I was a researcher doing work primarily in medical electronics and defense related areas, and we were trying to build cubic millimeter computers. So think an entire computer in 1 cubic millimeter. You've got a battery, a microprocessor, a radio, a sensor, all in 1 by 1 by 1 millimeter. And as you can expect, with a battery so small, the key constraint there is you've got to get the power that your system uses down such that it can fit in that tiny battery footprint. And so we got really good at building low power processors. Back in 2010, I spun that company out of the University of Michigan and formed Ambiq. And since then, Ambiq has been focused on delivering the world's most energy efficient solutions for anybody looking to add intelligence to their device. And we've shipped north of 230 million units at this point. So, my guess is if you're
Wow.
walking down the street today, you're going to pass a lot of people wearing our technology on our wrist, carrying it around in their pocket, any number of other things. So we're definitely putting intelligence everywhere as originally targeted.
Well, that's amazing. And as someone who was involved personally with the first single chip Bluetooth radio 20 years ago, it's amazing to see how far we've come. At that time, the idea of putting digital and RF on a single chip was CMOS
Yeah.
was a huge leap forward. Of course, you've come many generations since then. And explain, the unique aspect of your technology, how it works, and why it's so important for not just low power. You call it super low power. I guess there's a
Yeah,
T-shirt out
yeah,
there with
yeah.
that somewhere. But how does it work exactly?
Okay, so we, as I mentioned earlier, we have a unique technology called subthreshold and near threshold operation. And as I said, it's a concept that's been around for a while. Basic idea is this: in conventional chips, in normal chip design, we represent digital ones and digital zeros with voltages, right? Digital zero is 0 volts. Digital one is some much higher voltage, maybe 1.2 volts or 1 volt or zero point 0.8 volts. Energy in a system, though, is consumed every time you're toggling between 0 and 1, and the higher that voltage, the more energy you're consuming, and it's voltage squared. So right, as voltage goes up, we get energy going up quadratically. So if you can drop voltage down, there's big energy savings to be had, right? And the problem is that the transistor, the underlying switch in the circuit, needs a certain voltage to kind of fully turn on. In subthreshold and near threshold circuits, we say, you know what, we're going to flip that on its head. We're not going to fully turn the transistor on. We're going to raise the voltage up just enough where it still acts a little bit like a transistor, but it's not fully on in the conventional way.
Wow.
And so we do that. We get a big savings, and the net result is you're kind of using noise to do computation, and it comes with a whole host of challenges, as you can imagine. It sounds simple, right? Drop the voltage, get energy savings. But it turns out that we're exponentially or near exponentially sensitive to a lot of things. So temperature variations, environmental temperature variations, we're exponentially sensitive to that. Manufacturing variations. You look at the most advanced nodes these days, and there's a lot of variation. Two nominally identical transistors look very different when you look at them under a microscope. We're exponentially sensitive to that. We're exponentially sensitive to voltage fluctuations. So it's hard to design in this region. Your typical companies have avoided it. And we at Ambiq have built a whole technology platform that we call SPOT, subthreshold power optimized technology, to address that. And it's a whole host of things that we do. It's new library design techniques. It's proprietary architectures on the analog, digital, and memory. It's production test and trim techniques. So there's a whole bunch of things that we do to make that possible. And over time, that's added up. And as I said earlier, we've now shipped several hundred million units of the technology into all sorts of interesting applications. So it works. So it's a hard technology to master. It's one that we've spent years mastering. And then now it's a platform that I can go build a lot of different things. So we today sell a whole host of microprocessors covering a range of price points and feature points and performance points. And you can expect much more of that to come in the next few years.
Amazing. Well done. And tell us about your Apollo processor. When my audience thinks processors, they're going to think ARM and Intel and
Hmm.
Qualcomm. No small feat
Hmm.
developing a processor. So, what were some of the challenges, risks, I guess,
Hmm.
and what was the big
Hmm.
idea, with your own processor?
Well, so we first of all we are these are ARM-based processors that we build.
I see.
We and that's part of the beauty, right? Um, I'm enabling my customer to use the thing they're familiar with. Use an ARM-based microprocessor, but I'm doing so in a way that they magically
Got it.
get energy savings, right? So our technology is such that I can apply it below the architecture level. So the software experience is the same as what they get elsewhere. These are Cortex M class cores from ARM, so they're microprocessors that run up to 250 megahertz. The latest release, the Apollo 5 generation, is a Cortex M55. So it's a processor that is nice and lightweight. You run a real-time operating system, but then it has a little vector compute unit, so the so-called helium vector compute unit, so that you can do 8 multiplies in a single cycle if you're running neural networks or if you're running filters or signal processing operations. So it's a really versatile little compute engine. What's cool is we also have, because Spot is so versatile, I can bring in all kinds of other IP. We have a GPU on board. So a lot of our customers have big displays, rich displays, and they need to do it efficiently. Well, we've got GPUs on board that allow us to run with great efficiency. All sorts of audio peripherals, tons of memory. So when I say tons of memory, I mean on the order of 8 megabytes of total memory. For the big microprocessors, the Intels of the world, that's small, but for your embedded world, that's a whole a very large amount of memory for them to exploit. And the wild thing is our customers eat that up as quickly as we can design it. Right? You've got graphics that needs big frame buffers. You've got neural networks increasingly being used by our customers, and the memory needs of that are really insatiable. So really interesting products. I'd say what is challenging for us is just the breadth of customer requirements. We serve, I rattled off some of the markets that we served before: consumer wearables, medical devices, some of them wearable, some of them, patches, all sorts of different things. We serve smart credit cards, we serve wireless sensors, machine health monitors, livestock trackers. All of these markets are slightly different. They have different price points. They have different memory points. They've got different peripherals that they need. And so, offering a portfolio of products to meet all those is the challenge. And that's a good challenge to have. We're a small company, and to have customers kind of clamoring for your product is a really good problem to have.
Well, congratulations on that. And I think you even just recently won an award at Embedded World. So that must have
Mhm.
been very gratifying, satisfying to see the recognition there. And speaking of
Absolutely.
customers, what is a typical engagement with an OEM look like? And you imagine these design cycles are quite long. How early do you start these days, and any shortcuts or hacks to
Hmm.
kind of get started to get to market faster, which is the name of the game?
Right. Yeah, so it depends from market to market. We have a lot of consumer electronics customers, and it blows me away how quickly they can move.
Mm,
We have consumer electronics customers in China, in the U.S., in Europe, and the speed at which they move is wild. So it can be as short as a 6 month engagement before they start ramping to production. It can be as long as 18 months. And what we try and do is accelerate that early development. Sometimes for alpha customers, for early engagements, what we'll do is we'll give them even an FPGA version of our chip to get them going. Right, is we're designing the chip. Here's an FPGA that models what this chip looks like, and they can start porting their software. But for a lot of other customers, we'll give them access to the silicon, and at this point, we've helped so many customers port from other competing products that it gets to be pretty straightforward. And as I said, we're using standard ARM cores, and so the software porting process is relatively straightforward. When we were a small, early stage company, we had great hardware, but our software needed to catch up. It was difficult to use. The feedback from the customers was, "Hey, I love your hardware, super low power, but man, the software's got to come around." Well, in the last 5 to 8 years, let's say, we've made huge overhauls to the point where our software is extremely easy to use. And it's not just when I first started this company, a lot of what we provided to the customer was here's hardware and here's some a low level board support package and hardware abstraction layer. Customer, go do everything else. Well, these days we're providing a complete solution, right? You go in there and you say, okay, here's a Bluetooth stack that runs your full connectivity stack. Here's a graphics stack that you can use to run your UI. Here's a security stack, right? So we're providing end solutions. And the newest bit of that is we're providing a neural network stack. So we have a product that we call Neural Spot. And this is, everybody's heard of TensorFlow. That's the training framework that Google provides so that you can go build your own neural networks. Well, down here is the Apollo processor.
mm.
That's bare metal, but there's this gap you have to fill, and that's what our Neural Spot product is. It's the glue that gets you from TensorFlow down to bare metal. And then what we also provide along with that is what we call AI development kits, and these are pre-trained models, neural network models that we have some in-house experts that created them. We provide open source data and the model itself, the weights, everything you need to train your own model. And the idea is not that you would take that model to production, but that you can use it to seed your own efforts. So you're asking, how do we get these customers going and speed them along? Well, do a portion of the work for them and then let them mimic it. And right now, the hottest thing going is how do I get inference on my chip? How do I get neural networks on my chip? And so we have to give them the tools to do that. And I would say that 7 or so years ago, when I started looking at neural networks, I was intimidated by it. It felt like this thing that you needed to have a PhD and years of experience to take on. But these days, that's not true. We have an expert, our VP of AI, named Carlos Morales, and he's the one who showed me that, hey, this is all very something that is attainable, right? You get yourself, you don't need a cloud's worth of compute. You get yourself a good gaming PC on the desktop. You can train models. You can build your own neural network models. You can copy or not copy, but you can emulate the neural network models that are being published weekly in various papers, and go build and experiment yourself and iterate. So we've been building a lot of models internally, and we're trying to show our customers that, hey, you too can develop these. So a lot of amazing tools out there, some of which we're developing in house, some of which we're getting from partners. But these days, it's getting a lot easier both to develop all the graphics and connectivity software, but also the neural networks that I just mentioned.
Wow, that's so exciting, particularly when you see all the open source models and tiny ML, everything's playing right in your
Yeah.
house. Maybe talk about your and the team you built, the growth trajectory you're on. Where are folks located? What's been the secret sauce
Hmm.
to the culture and the
Yeah. Yeah.
co-working environment you have there?
So I'm located in Austin, Texas. And that's where we were basically founded, spun out of University of Michigan, moved here and built the core team here. But over time, we've become a multinational company. So we're a roughly 200 person
Mm.
company. I'm going to say roughly half of that is in the US, and then the other half is split between strategic sites in Europe, Singapore, China, and Taiwan. So, and Japan. So very much a multinational company, doing technical development both here in the US as well as elsewhere. And there's a number of tenets of the culture that we've built here, but one of those is innovation, and another one involves putting the customer first. So I think what you'll find at Ambiq is a company that's built around we're going to innovate, we're going to be aggressive, we're going to put out new products that are lower power every year, but we're doing so in service of the customer. And hey, every business is serving customers, right, in some way. But I think we really put that at the forefront here, and our customers would say the thing we like about Ambiq is that yes, they offer low power, but we also know that Ambiq's going to bend over backwards for us. So I think we've been really nimble and agile on behalf of our customers, and I'm proud of that. So the team is obviously we have a big chip design presence here at Ambiq, but increasingly, as I was just alluding to earlier, software is a big piece of what we develop. So between
Mm.
our software and solutions team, which is developing all kinds of enabling software, as well as our AI team, I'd say there's probably more people at Ambiq today writing software than there are building hardware, which I think is pretty typical of a chip company these days.
Indeed, probably the same at your big OEM customers. And maybe talk a little bit about the semiconductor space. You probably as excited as many of us are to see the renewed focus on chips and silicon and semiconductor manufacturing, even in your neck of the woods, your backyard. Um, what's the opportunity there for you, but also for the industry? Do you think?
So, this one's been a long time coming for me. Everybody this is the only company I've ever worked for. Okay, Ambiq is my company, and that's the only company I ever want to work for. But when I talk to all the experts that we've got on our team, what they see is there's cyclical nature of this industry. We go up, we go down. But when I first founded the company, we were certainly in a trough. It was very hard to build a new chip company. Everybody wanted to invest in software. But we saw vision of hardware becoming important, especially as intelligence. There was this IoT thing that was being theorized, right? When I first started the company, and I had to explain to investors and VCs what is this Internet of Things. Well, it's being fully realized now, and I think everyone's realizing, especially when you look at the data center and look at the proliferation of AI, that oh my gosh, hardware is actually quite important. Clearly, it's at the center of geopolitics these days too. And we found ourselves very much at the center of that, right? So um, China remains an important market for us. Taiwan is an important manufacturing site for us, and so we pay close attention to all that. So I think I guess I'm happy to see that hardware has become important. I'm let's say very closely tracking all the geopolitical interest in the semiconductor space and in the hardware space. And I'm pleased to see that various governments all over the world are really investing in that. And I think that benefits us. It benefits everyone else in the space. So it's been an interesting few years for sure. And I think the companies that are doing well and thriving are the ones that have stayed nimble. And that's back to values of the company. One of the values certainly is that Ambiq has to stay innovative, but also nimble, and that means keeping up with the changing geopolitics around semiconductors and hardware.
Such a fascinating area to watch. Let's talk a little bit about sustainability. Low power is not just a nice to have these days; it's a must have. From devices right through to the data center. Everyone talks about the compute, the power requirements of AI. Challenging to say the least. It must be rewarding to
Mhm.
be involved in that sustainability discussion. And it's important for many industries, healthcare and wearables and other things. How do you think about sustainability
Yeah,
from a chip manufacturing standpoint?
energy is at the center of everything, and I started. It was clear that energy was important for battery powered devices, but what's become very clear lately is that it's just as important, if not more important, for the data center. To your point, right?
Mm.
Everywhere we look, there's this need to cram as much compute as possible into a fixed power budget. For me, it's a battery that's inside this watch. for the data center, there's only so much power that nuclear power plant can deliver to the data center, right? So we need to get as much compute as possible in there. And then there's this other thing too, which has become obvious, is that all the devices that we've enabled over the past few years are generating phenomenal amounts of data. And the inclination, I think, for a lot of the vendors is, well, let's just send it up to the cloud and we'll do the compute there, right? So, my watch has two choices. It can either take all my raw heart rate data and the microphone data and motion data and send it up to the cloud, or it can do the compute locally. And if you go do the analysis, it's just completely unsustainable to send it to the cloud. I have no hope of powering all that, right? If every smart device in the world, for every person was sending data to the cloud, it would just be a completely unsustainable thing, right? So we're really focused on how do we do that compute locally. And so I think that is an important sustainability play. We don't have room to build a nuclear power plant after nuclear power plant to supply energy to all these data centers. And so we view the edge devices, the endpoint devices, as kind of the front line in that barrage of data, right? And so we have to do our best to sort through it. We get asked a lot by shareholders, by customers, by partners. Hey, where does AI reside? Should it be in the cloud or should it be at the edge? You can make a good argument for either. And the fact is that both make sense, right? These have to be the eyes and the ears, and the noses, so to speak, of the data center counterparts. But they have to do some work. They have to parse through this wave of data that's coming and only send up the salient points to the cloud for further consideration. So it is certainly satisfying to be part of that. And we're doing our best to make sure that the stream of data that's flowing from these devices to the cloud is actually very minimal. It's more of a trickle, I think.
Well said. How do you think about your innovation and roadmap long term, maybe 5 years out? Are you thinking about areas like 6G, for example, or is you need to look closer to home? Are these
Yeah.
5+ year standards a little too far out of range for you?
Well, first of all, I'm really excited about where we can go in the next 5 years. As technologists, I was just giving a seminar to some of our internal team yesterday, and what I said is, hey, I'm really proud of what we've accomplished, but there's a big gap between what we've accomplished and what's possible, and we've got to start working on closing that gap. Um, so what's ahead for us? Well, for one thing, Moore's law is alive and well in the embedded space. So we're building processors today that I'm really proud of, 250 megahertz. These are in 22 nanometer technologies. But look, the bleeding edge for the data center for phones is down at 4 and 3 nanometers going to 2 nanometers. There's a big gap there, and there's a reason that embedded computing like our chips lags behind. But we have a lot of room for Moore's law. We partner closely with TSMC, our manufacturer, to make sure that we can jump to these new nodes. So that alone is giving us huge performance benefits. So you'll see products from us coming that are really, really high performance. Okay, as we scale to these more advanced nodes. The other thing that's exciting is as the workloads used by our customers are increasingly becoming AI, they're becoming neural networks. That is a very parallelizable workload. It's the kind of workload that really benefits from new architectural innovation. So instead of, I said earlier that Apollo 5 can do 8 compute operations in a single cycle. Well, what if we could do 256 or 1,024
Mm.
Mac operations in a single cycle, right? That means you can run at a relatively low speed and get enormous performance. So you combine that with going to advanced nodes, and what I foresee is that the amount of compute that you're going to be able to put inside of a tiny little battery powered device like this is going to be phenomenal. It's going to be unimaginable. And so
Wow.
what can we do with that, right? That's the question. And we've got some AI experts at Ambiq who are there every week. They're tracking all the latest publications, and what we see is these models keep getting bigger and bigger. But what we also see is that the models that are tuned for the edge are getting more and more capable. And so my objective here is to enable our customers to put as big of a model as they can possibly conceive of inside of these little battery powered footprints. And it's when we do the back of the envelope math on what should be possible, it's going to be amazing. We're going to see certainly true natural language processing on endpoint devices like this, meaning I'm going to be able to talk to all my electronic devices as if it's you I'm talking to, and not a thing that understands only the Alexa keyword or something like that. And we're also going to see the introduction of camera as a sensor in a lot of these devices. So problem with cameras is they there's a mountain of data that those things produce with every frame, right? Every high definition frame comes along and it's a ton of data. But we have products coming that are going to be able to handle that mountain of data quite well. So in the next 5 years, actually, the best sense of what's coming in the future is to look backwards. As I said, I was giving a seminar to my team last night. I compared the latest Apollo 5 processor to our original Apollo processor that was launched about 9 years ago. And there was a 10x increase in performance over that time in terms of what a microprocessor can do, and that was accompanied by anywhere from a 5x to a 20x improvement in energy efficiency. So extrapolate that forward, it's going to be amazing what we can pack into tiny little batteries. So I'm excited about what's coming.
Yeah, well, I'm certainly intrigued and excited by your vision of where we're headed. So amazing. One last thought here before I let you go. Any advice to aspiring technologists, entrepreneurs, maybe out of or in academia at the moment? What was that journey you, and any advice you could give to them?
Yeah, there's two things. There's two bits of advice that I always give to entrepreneurs. One is if you're coming out of university, take advantage of the resources there. The minute you take money from an outside funding source, there are consequences to your action, right? And actions, and so
Mm,
suddenly you have shareholders, you have other stakeholders that are, and you're on a clock. When you're at a university, you've got access to incredible resources. You've got an office of tech transfer. You've got a lab. You've got professors. Take advantage of that. So if you're coming out of the university, don't be in a
mm.
hurry to leave the university. The other thing I always say is, um, I'd say the difference between a successful entrepreneur and one who is unsuccessful is usually not the idea. It's not your technology. It's not the idea that you had. It's how persistent you were. Are you willing to break through every last brick wall that's placed in front of you? And that's one thing that we've been good at Ambiq. Look, there's so much that we can't control. Since I founded the company, we've faced COVID. We've faced all kinds of interesting geopolitical tensions between countries. We've seen capacity shortages in the industry. We've seen over inventory problems at customers. These are all things I can't control, right? And so, as an entrepreneur, what you have to do is you have to navigate all that stuff effectively, and that is usually more important than how great your idea is or how exciting your first market is.
Well, such an important sentiment. Well, thank you so much, Scott, for sharing the vision and the mission. We're all watching, many of us rooting for you, and can't wait to see the next big leaps.
All right, thank you, Evan. Really appreciate the time.
Thanks, Scott. Likewise.
Okay,
Take care.
bye.
Take